So some other types of problems that you're going to see would be like number 4. It says in your checking account, you put in $100 to start the account. After 2 years, you had $388 in the account. And then after 3 years, there was $532 in the account. It says, assuming your checking account is increasing linearly, write a function to model the money in the account after so many years. Okay. If you look down here, it says interpret the domain and range. Well, look at what your X values are. It says after X years. So your X values, which is your domain, is the number of years that you're going to have the account. And then the range, so this is your domain. The range in this problem would be whatever you're going to get out of this equation. So it says write a function to model the money in the account after that much time. So what this equation is going to tell you is how much money you would have in the account. So the range would be the amount of money in the account after so many years. Okay, so we went ahead and did that part. And now we have to write the function to model this equation. Well, in the other problems that we've had, you'll notice that they tell you how much is happening or how much you're going to pay per month. Here, it's just telling you how much you've had in the account after so many years. So they're not really telling you how much you're putting in this account. And so what you have to do is actually find that. It tells you how much you're starting with. It tells you how much you're going to start with. So remember, that's your y-intercept. But it's not telling you how much you're putting in the account on a yearly basis. So you have to find that. Well, that would be your slope. So if they don't tell you, you actually have to find the slope yourself. Notice they do give you 2 points in time. They tell you after 2 years, so notice what I'm doing. After 2 years, you end up with $388 in the account. And then after 3 years, you end up with $532 in the account. Okay, that is 2 points in time. And so I just wrote them as coordinates. And now I'm going to find the slope using my slope formula. So remember, you take a y value minus the other one. So it'd be 532 minus 388. And then on the bottom, since I started with this point, on the bottom, I'm going to take 3 minus 2. And then I just find my slope here. So on top, I'd get 144 when I subtract them. On the bottom, I get 1. So my slope is 144. And so remember, this is the money in the account. That's the year. So this would be how much you are putting into that account each year. So it's money per year. So we're kind of combining what we've talked about the past couple days. So now you can write your equation. So to find the amount in the account after so many years, I'm going to take, I'm putting in $144 per year, and they want us to use an X for that. So 144 times X, 144 per year, plus I have already put in 100 to begin with. So there is my equation. So if you wanted to know how much money you would have in the account after 10 years, you could just plug an X in there and it'll tell you how much you'd have after 10 years. Okay, so the last kind of problem we're going to talk about is just observing kind of a pattern and going from there. So it says, James and Ryan are collecting bottles for recycling. The total number of bottles collected for the first few days are shown in this table. And then it says, based on the pattern, on which day will James have collected more bottles than Ryan? So if you're just observing, you can kind of see what the pattern is and keep the pattern going to kind of get an idea of as to what your answer could be. So we're looking for which day will James have collected more bottles than Ryan. Okay, so right now, James on day 1 collected 1 bottle, whereas Ryan collected 5. On day 2, James had collected 2. On day 3, James had collected 4. On day 4, James had collected 8. Versus looking at Ryan, Ryan collected on day 2 15, then 25, then 35. So let's find the pattern. So for James, what's going on from day to day? What's happening? And it looks like it's going up, but what's the pattern? Well, notice to go from like 2 to 4 and 4 to 8, that's actually doubling. So James is actually doubling how many bottles he's collecting. Versus if we look at the pattern for Ryan, well, it looks like Ryan's just collecting 10 extra bottles each day. And so we're going to keep these patterns going, and we're going to look at what point will James have collected more than Ryan. Because if you're multiplying how many bottles you're collecting by 2, you will eventually pass, or he will eventually pass Ryan. So on day 5, how many bottles would they have collected? Well, James is doubling. So on day 5, if we take that and multiply by 2, he would have collected 16. Versus Ryan is just adding 10. So if we add 10, he would have collected 45. So let's keep the pattern going. So on day 6, 16, if we double it, we get 32. And I'm going to just finish James. I'm going to do a couple more for James. So on day 7, he would have collected 64. And then on day 8, 128. And then we could keep going. But I'm just going to get a few, and then I'm going to compare. So Ryan, on day 6, I got to add 10 more, would have collected 55. On day 7, he would have collected 65. And then day 8, 75. And then 85 and 95. So let's compare. So we're looking for the day that James collected more than Ryan. All right. So comparing on day 5, James collected 16 versus Ryan's 45. So that's not more. On day 6, 32 versus 55. James still hasn't collected more. On day 7, he's closer, but he still did not collect more than James, or more than Ryan. But then if you look at day 8, on day 8, James collected 128 versus Ryan only collected 75. So day 8 is actually the day that James had collected more bottles than Ryan. So the answer would be day